Hi, so I'm going to do number 43 from section 1.3, and it reads the square root of 225x cubed divided by 49x. And all of this is inside the radical. Remember, there is an invisible index 2, so really we're thinking about it as this whole expression to the 1/2 power. And this exponent can distribute. Again, I don't like using that word because distribution normally implies over addition and there's two operations involved, but we are sending this 1/2 to the exponent 1 and multiplying. So we've got 225 to the 1/2 power. And we're taking 1/2 times 3. And if you can recall multiplying a whole number by a fraction, you think of it as 3 over 1 times 1/2, and you multiply straight across. And so you get 3/2. So we have x to the 3/2. We're going to get 49 to the 1/2 power, and we're going to get x to the 1/2 power. So we're thinking about, well, what is the square root of 225? Well, the square root of 225 is 15. What is the square root of 49? Well, the square root of 49 is 7. And now we begin to do that little trick that we did earlier. And x to the 3rd power, the square root of x to the 3rd power looks like this. You have the square root of x times x times x, and you have a pair of x's. So 1 gets to come out, and that x stays underneath. So you're really looking at x times the square root of x, or you could write it as x times x to the 1/2 power. You have x to the 1/2, that's just the square root of x, and those will cancel, and that will leave you with 15x over 7. Now, I'm also going to do number 49 from that section. And the problem begins here as the square root of 8 over 1 minus the square root of 3x. And to get rid of radicals in the denominator, we either rationalize or we use the conjugate. So in this example, we're going to use the conjugate of the denominator. And what that basically tells you to do is you keep the terms the same, but you change the sign of the second term. Or you can say, well, I turn subtraction to addition, or I turn addition to subtraction. And so that we're not changing the value of the fraction, we're going to multiply top and bottom by the same thing, effectively multiplying by 1. So we'll distribute the top, and so we get the square root of 8 plus the square root of 24x, because 8 times 3 gives us that 24. And in the denominator, we're going to get 1 times 1, which is 1. 1 times the square root of 3x is the square root of 3x. And negative square root of 3x times 1 is negative square root of 3x. And negative square root of 3x plus the square root of 3x actually becomes the square root of 9x squared, but the square root of 9x squared is 3x. Now, I will make this comment. We are assuming that the value is positive, so that this can come out without having to deal with absolute values and so forth. But back to here. These two drop out, so we have in the denominator 1 minus 3x. And we can play around with this top a little bit. They both have the square root of 8 in them, so I ended up pulling out the square roots of 8. Square root of 24 is 8 times 3, and we just break up the radical. So it's 8 to the 1/2 power times 3x to the 1/2 power. And we factored out a square root of square root of 8, and that sits in front. We have 1 plus the square root of 3x all over 1 minus the square root of 3x. All right, hopefully that helps.